Lesson 7.4 in Algebra 2. We'll be looking at algebra functions, really focusing on performing arithmetic on functions, as you can see our learning target up above. So we'll be adding, subtracting, multiplying, and dividing functions together, but we're also going to be asked to find domain. You can see I've highlighted in green up here. Domain is always referring to x values. Which x values are allowed? Actually, there are two main problems that we can have. Sometimes if you were to substitute in an x value, you might have division by 0. You would see an error show up on your calculator, meaning that x value should not be allowed to be plugged in. In a similar way, you can have x values substituted into even indexed roots like square roots, fourth roots, and so forth, where you have a negative inside. And if that's the case, then you'd also have an error. So that's really what's happening with domain. We'd like to know if there are any x values that we would not be allowed to use. Take a look at example 1, though. We have f of x is x squared plus 1, and g of x is 3x minus 2. H of x, plain and simply, is f minus g. So what we do is we just follow these directions. We're going to take function f, which, by the way, is x squared plus 1, and we're going to subtract 3x minus 2. That's your g of x. When we have these subtractions, of course, you can distribute your negative. Here you'll have x squared plus 1 minus a 3x and then a plus 2. And as you combine your like terms, you'll have x squared minus a 3x, then a 1 and a 2 will add up to a 3. So your h function is actually right here, x squared minus 3x plus 3. Notice that for our domain, any x value would be allowed to be plugged in. You would never see a fraction which would indicate division. You don't have any roots at all, any radicals, so we don't have to worry about having negatives go inside even index roots. So honestly, the most common domain answer that we're going to see, at least in this section, would be all reals. There are exceptions, we're going to see that in a moment, but more often than not, if you don't wind up with any fractions, if you're just adding or subtracting functions together or multiplying them, you'll see that your domain is all reals. In a similar fashion, take a look at number 2. H of x is f, which our f function could be x to the third, and g of x is down here, we'll have 2x. Now this problem is in fact noticeably different. It's noticeably different because we have a fraction. And the problem that we're faced with is there are ways that you could get a 0 in the denominator, or there is a way. Look, what we could do very quickly is make a fraction show up, alpha y equals, and let's just say I plugged in the number 0. I'd have 0 to the third. Down below I'd have 2 times 0. The problem is my denominator would be a 0 at that point. Hit enter and immediately you get an error message. In other words, 0 is not allowed in our domain. So that's a restriction. Any other number would be okay, but not 0 itself. Now with this denominator of 2x, another way we can go about that, some students feel comfortable taking that denominator, writing the cannot equal 0, and then solving. This is another way that you can find your restriction. Don't worry about the top, it's just the denominator. Say that denominator cannot be 0. Solve just as you would solve an ordinary equation, and you'd come up with x cannot be 0. Well, as always, when you have fractions, you should reduce whenever you can. X goes into x to the third. You're going to cancel one x from the top. Your final answer is x squared all over 2. I want to point out too that even though we did reduce, the reduced form is not where you should be looking for your restrictions. If we were just looking right now at my circled answer of x squared over 2, you'd never know that 0 isn't allowed to be plugged in. And the reality is you cannot. You have to look prior to simplifying, because simplifying just means you're going to divide the same number out from the top and from the bottom. You can't divide a 0 from the top and from the bottom to cancel in that regard. So always check for restrictions before you simplify. Well, that's all you need to be able to do worksheet 7.3 and 7.4, the combination of them. I'd like to introduce the composition of functions. The composition of functions is really a nice follow-up part of this lesson. You'd be given two functions, f and g, but notice what I've highlighted here. This looks very much like multiplication, and yet it is not. Multiplication will always have a multiplication symbol between them, like f of x times g of x. Here we're going to notice that really we can't have that hold true for compositions. Compositions will have f and parentheses g of negative 2. Back in 4th or 5th grade, you learned that you always have to work from the inside out. So that's really what we're going to have to do here. We're going to evaluate the function of f at g of negative 2. We first find g of negative 2. Now g of x is x squared plus 1. And what many teachers do, I do this myself, is wherever there is an x, I put in a blank with parentheses, especially for any x. And the reason why we have that is so that we can see that whatever gets substituted on the left side would get substituted on the right. You can substitute another variable. You can even substitute a symbol like a triangle. This would be a triangle squared plus 1. You can just as well plug in a number. That's essentially what we're going to do right now. G of negative 2 then is negative 2 squared, inside parentheses, mind you. Negative 2 squared with those parentheses, well, that works out to a 4. Negative 2 times negative 2. A negative times a negative is a positive, and 4 plus 1 is 5. So g of negative 2 is 5. What that really means is this yellow portion, that highlighted g of negative 2, is really the number 5. So now we evaluate f of 5, and then we'll be done. F of x, as you look at the top of the screen here, we have 2x plus 7. We can say f of a blank equals 2 blank plus 7. So when you plug in a 5, you'll have 2 times a 5 plus a 7. That's 10 plus 7, which works out to 17. And that's your final answer.